Welcome back to SpaceX Daily, episode 44. I'm Patrick in Vancouver. Today is July 25th, 2026. Let's get into today's SpaceX developments. Starship Flight 13's V3 Starlink deployment and intact splashdown clears the path for a tower catch attempt on the next flight. SpaceX launched the 13th Starship test flight from Starbase, Texas at 5:51 p.m. Eastern Daylight Time. The 397-foot-tall, two-stage vehicle lifted off under 33 methane-fueled Raptor engines, producing roughly 16 million pounds of thrust. The upper stage deployed 20 next-generation Starlink V3 satellites during the mission. The stage then splashed down intact in the Indian Ocean after completing its objectives, though the landing profile was imperfect. This flight marks the first Starship test since the June 2026 IPO and continues the ongoing campaign that last appeared on air in EP 43 on July 24, moving the orbital refueling and reuse milestones forward by demonstrating payload delivery under near-full propellant loads. The July 25 test marks Starship's first flight after the company's NASDAQ listing on June 12, 2026. The mission focused on satellite deployment and recovery data collection under the post-IPO operational spotlight. This flight supplies the first public performance data point since the largest IPO in history raised roughly $75 billion at a $1.8 trillion valuation. The outcome feeds directly into the reuse and refueling timelines that determine future launch economics. Source reports from Google News note the post-listing timing as a key marker for public performance tracking. The event also supplies early post-IPO data on how the vehicle handles near-full propellant loads during ascent and separation. The 13th flight carried and released the first batch of next-generation Starlink V3 satellites. Deployment occurred despite the vehicle's non-nominal landing profile. The satellites represent an upgrade path that directly supports the constellation growth and direct-to-cell open questions tracked for the Starlink program. Early reports indicate the deployment sequence completed its primary objectives before the upper stage re-entered. Google News coverage highlighted the V3 batch as the initial on-orbit demonstration of the upgraded hardware. Community observers on r/SpaceX linked the successful release to potential schedule impacts on direct-to-cell service expansion. The 397-foot-tall two-stage rocket lifted off under the power of its 33 Raptor engines. The flight advanced Starship's test campaign toward full reuse goals by demonstrating controlled ascent and stage separation. Reports describe the overall test as mostly successful, even with the noted landing imperfection on the upper stage. The booster's performance adds to the dataset on engine reliability and propellant management at scale. Google News summaries emphasize the Super Heavy contribution to reaching the velocity required for orbital insertion. The booster segment also supplied additional telemetry on methane-fueled engine cluster behavior during the initial ascent phase. SpaceX confirmed splashdown of the Starship upper stage following the 13th test flight. The vehicle completed its primary objectives of satellite deployment despite an imperfect landing profile. The confirmation came via official channels and was highlighted in community threads as a positive data point for future recovery hardware. This outcome supplies additional flight data on heat shield and attitude control performance that the program needs before attempting tower catches. Reddit threads on r/SpaceX noted the intact ocean impact as evidence that current recovery systems can tolerate non-nominal conditions. The splashdown dataset now includes real-world measurements of thermal loads during re-entry. With the flight data now in hand, the next obvious question is how quickly SpaceX will close the remaining gap to full reuse. Elon Musk posted on X that SpaceX will attempt to catch the ship with the tower on the next flight unless post-mission data review reveals problems. The statement came after the 13th test flight successfully deployed satellites and confirmed splashdown. The comment directly addresses the central open question of full and rapid reuse that the program has tracked since the prior episode. Observers noted the announcement as the clearest public signal yet on the timeline for the first tower catch attempt. While the Starship team reviews that landing data, another part of the Musk ecosystem moved at its own rapid pace. xAI released Grok 4.6 and 4.7 back-to-back, establishing a release cadence unmatched by other frontier labs. The updates continue iterative model improvements running on the company's expanding compute clusters. This development sits within the broader Musk compute ecosystem that now includes SpaceX and Starlink infrastructure for potential backhaul and orbital data center concepts. No specific cluster size or training run details were disclosed in the reports. Meanwhile, the company's more mature launch cadence continues on the West Coast. SpaceX is preparing a Falcon 9 launch from Vandenberg Space Force Base for Saturday morning. The mission continues the company's high-cadence operations on the West Coast pad, where booster reuse counts keep climbing. This launch sits outside the Starship campaign and helps sustain the annual launch rate ceiling that remains a key open question for the Falcon program. No payload details were released in the targeting notice. Google News targeting notices placed the Saturday morning window as the next scheduled West Coast activity. The mission supports ongoing booster flight counts that continue to rise with each reuse cycle. Observers on SpaceX highlighted the rapid turnaround from the prior test flight to this successful deployment. Some noted the vehicle's survival in the ocean as a positive data point for future recovery hardware. Community threads discussed how the V3 satellite's performance could affect direct-to-cell timelines. Multiple users flagged the Musk Tower Catch statement as the clearest signal yet on reuse progress. Others compared this flight's timeline to earlier Starship tests that ended in loss of vehicle. The discussion threads also examined how the intact splashdown data might influence guidance algorithm updates ahead of the next mission. Worth keeping an eye on, several reports described the landing as imperfect even though splashdown was confirmed. An imperfect profile leaves open questions about thermal protection and control margins that must be closed before tower catch attempts. Resolving the issue would require post-flight data review of guidance, navigation, and heat shield performance. Counterpoint coverage in multiple outlets stressed that these margins must be quantified before any tower catch hardware is risked on ascent. The review process will examine entry guidance logs and tile performance metrics collected during the non-nominal descent. On the AI front, xAI released Grok 4.6 and 4.7 in immediate succession, establishing a release pace not yet matched by peer labs. The updates continue the company's push to iterate models on its expanding compute clusters. This activity occurs within the Musk ecosystem that increasingly links xAI training runs to SpaceX and Starlink infrastructure for potential backhaul and orbital compute concepts. No specific details on cluster scale or cross-company data sharing agreements were disclosed in the available reports. Google News aggregations framed the back-to-back releases as a distinct operational tempo within the frontier model space. From an engineering standpoint, the 13th flight demonstrated Starship's ability to carry and release a meaningful payload while surviving re-entry and ocean impact. At the core of this result is the two-stage architecture. The Super Heavy booster's 33 Raptor engines provide the initial 16 million pounds of thrust needed to reach the velocity for orbital insertion, after which the upper stage's own Raptors handle the final circularization and deorbit burns. The intact splashdown shows that the current heat shield tile layout and attitude control margins can keep the vehicle within survivable thermal and structural loads even when the landing burn is not perfectly executed. That margin matters because every extra kilogram of propellant or structure saved on the upper stage directly increases the payload that can be delivered to orbit or retained for a tower catch. The design choice to fly a near full propellant load on this test also validates the tank and feed system performance at scale, reducing uncertainty around the orbital refueling demonstrations required for deeper space missions. The flight therefore supplies concrete data on how the current thermal protection and guidance stack behaves under real re-entry conditions rather than relying solely on ground test extrapolations. Next flights will likely tighten the landing corridor by refining the entry guidance algorithms and possibly adjusting tile density or gap fillers. If those changes close the remaining gap, the program can shift from proving survival to proving rapid reuse, which is the step that collapses the cost per kilogram to orbit. The idiot index here is instructive. The raw materials and propellant inside a Starship upper stage cost far less than the finished vehicle, yet each successful recovery reduces the multiplier by amortizing the high-value hardware across multiple missions instead of discarding it after one use. Closing the landing precision gap therefore directly attacks that multiplier and moves the economics of orbital delivery closer to the theoretical floor set by propellant and metal prices alone. And a quick market note, SPCX closed at $115.07. Before we go, Starship's flight data now feeds directly into the next reuse milestone. That covers everything worth knowing about SpaceX today. SPCX is trading at $115.07, down 0.9%. A quick rating on Apple Podcasts or Spotify goes a long way. I'm Patrick in Vancouver. See you tomorrow. This show comes to you from the NARA network. If you want another sharp daily briefing, Environmental Intelligence has you covered. The Environment and Climate Policy Brief for Canada. All our shows are free at naranetwork.com. Prefer reading? Today's full write-up, sources, and transcript are on the episode blog at naranetwork.com. Same briefing, readable format. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.